Online folks, can you hear my voice?
Yes.
Um, I'm smart enough to brighten it. Now, picture would make more sense. Well, how's it going? So, pretty sure this is calculus, brief calculus, is that right? Okay, good. Thanks for coming to class, either in person or online. This class is kind of like a hybrid thing. Call it syncing. It's a sync session. So what I try to do is I try to introduce the material during our class time, but it would be assumed that we don't go over everything that you would need to know. But that means that there's some backup material to fill in those gaps. Okay, so it's kind of like an online class that has an in-person or online virtual session. So we only meet half of the time we need to meet. So that means there has to be some kind of way to fill in that gap. The good thing about this class is that it comes with the Pearson materials, and the Pearson materials, which is the textbook, online textbook, that's going to be the thing that fills in the gap. So I try to select problems that we can go over that would introduce the material, that you would, be able to at least get a good start on the material, but it would be assumed that we won't go over everything. I try to hit what I think is the most important thing or strategize it in that way. But of course, I can't go over everything because even in an 8-week course, we're only meeting half the time. We should meet 6 hours a week and we only meet 3. So that's part of it. My name's Ryan. I'm always worried about the technical details. So I'll teach this class kind of sort of backwards. What I've been doing as I've been teaching these courses in this way is I'll try to show a homework problem and then cram in lecture as I'm going through the material. And so I've kind of plucked things out of the textbook, like definitions, theorems, that kind of thing. And so I'll kind of do it backwards than it really should be taught. It really should be taught. We go over, theory, we go over the material, and then I'll show a few examples. And I'm going to do the opposite. I'm going to show an example and then try to cram in the theory while I'm doing the example. So that's just because of the time and material we're dealing with. So that will be why I do it. I think for the most part, it benefits the student. It benefits you more. It's probably what you end up preferring. So that's why I do it. But I might be I might run into problem 12 and all of a sudden it takes me 12 minutes to explain what this problem is. It's not because I'm solving it as fast as I possibly can. It's because I'm trying to explain the material, where this would even come from, why we're doing this, what it relates to anything else. So if you notice it, I'm not just doing um, as quick as possible. I'm just trying to explain the material. And that way you also get some um, examples of me doing homework in front of it. So that's the idea. Now, because of the hybrid nature of the course, everything as far as assignments, quizzes, exams, that's all going to be done online. So we're not going to do, even though you're in class today, we're not going to do homework, quizzes, or exams in class. That'll be done on your own time. So that's good and bad, right? That's good and bad. The good thing is you get to kind of pick when and where you take those things. So you get to kind of pick, when and where you take the quiz, when and where you take your midterm or final exam. That's nice because it's not just it's on this day at that time, and then if you can't make it, you don't get it, which is the way we used to do it, but that's not the way we do it anymore. So really, the quizzes are like timed homework, and the midterm will be like a big quiz, like a super quiz. So it's all done on your time, your laptop on. So we'll all take it at different times. So I think in some ways that's good because you get to pick your space, pick your time, when it's available, when you think you're ready. As opposed to it's in this room at 8 a.m., be there or get a 0 kind of thing. So that's helpful. A bad thing, at least you guys are in class, and the bad thing with the online classes, there's not a lot of crosstalk between students. We learn a lot from people that are learning the material for the first time. So, I guess I should place. Well, anyway. It is what it is. So we're gonna use the technology to our advantage in some ways, and in some ways it will be to our disadvantage. One of the things that I think is disadvantage is that um, when you have the online portion, it tends to be more time consuming, and there tends to be more homework assigned. Okay, so as the Pearson package, as it's set up, as the way the state Ivy Tech set it up, I think there's a lot of homework, to be done. Okay, I try to show a lot of problems and kind of speed that process up, but your problems will be slightly different than mine. And even if I do multiple attempts on it, it'll change the problem up. So I will just warn you, it is extremely time consuming. This class will be, any class like this is really time consuming. So waiting at all to get started is a bad idea. Okay, do not wait at all. Do not wait for me in any way to get started. So you will have to be very diligent on yourself to get started and to proceed. My guess is don't try to cram it in one day. Try to do it over a time period. A couple hours every day would be better than 8 hours on next Wednesday. Okay, because just like physical exercise, mental exercise, I mean, you go, oh, well, I could go to the gym 3 days a week, or I could just do it all in one day at the end of the month. No, that's not really how it works, and that's not really how our brains work, so don't do that. But I know you're busy, and I know you have other classes and jobs and family and everything, and me too. So I understand that, but I would be a little bit every day is better than a whole lot on one day. Okay, because there's just too much to be done, and you'll get tired too quickly. Right, so that's my suggestion and my warning, but once we go over some problems, I think it'll be more obvious of what is expected. Okay. Now, I know that a few of you have already looked at the book, looked at some of the material, so on, but I can't see this from your point of view. So I'm stuck in my point of view on this, but I know a few of you have opened. So has anyone been through our course website to the Pearson material? Has anyone seen it yet? No? Some have, some haven't. Okay. So my guess is, did you go to textbooks first to get to it?
I think I might have.
Uh-huh.
Because I did try to get into Pearson and first it wouldn't let me in for some reason. I had to log in, but it wouldn't accept me.
So I can show you where I go, and I know that some of you have done this, because I can see, once you do it, then it lists your username and that kind of thing. And of course, now it's being super slow. I have a frowny face of what I should have. That's not good. Okay, let's see what's going on. Another way to do it, maybe just go to assignments. This is what, okay, and then I have open Pearson. But it won't show me your point of view, it only shows me, and I'm the instructor, so it's slightly different. Hopefully it'll open up. The whole lecture is based on this working, so hopefully it does. So I have some homework problems. Here's the first homework. And I have, I have 40 questions and I have roughly about 60% of it done. So hopefully I can show you that. But that's something that I need you to do, probably start today if you haven't, is at least open that material. The textbook link should work, and if not, try to go to the first homework assignment, see how that works. I certainly won't be able to do tech help right now, but if you want to stay after class, we can look at it together. Try to go to textbooks. So, okay, now it's working. So when I went to textbooks here listed there, I can launch courseware. And this is the thing that will look different for me than you, because I'm the instructor, but it should look very similar once it loads. And that is how we will do our, so I would assume you'll have something like this with my math lab, all assignments. So that's something I need you to do today, because if it's not working, we need to figure out why it's not working.
I've always been able to access Pearson in every class for some reason.
It says you need to log in,
Link accounts.
link accounts. Okay, you're not in that? Yeah. Has anyone linked their account before?
No, never. This is the first time.
Has anyone in this class already done it? Yes. How did you do it?
Just use my Ivy Tech email as well.
Like where it asks for Pearson username? Okay.
Okay.
Thank you.
That's what I've done is. I'm not using a different password. We'll see if I did something.
Okay. Yeah, this is the problem, is that we've switched the way we do it and no one is telling me what it is on your side, how it works. I don't know. That is the frustrating thing. I won't be able to do it during class today, but if you want to stay after class, I can look at it on your laptop. But it sounds like it can be done, because it has been done.
Nope. The password didn't work.
You say you just used your Ivy Tech?
Like, I already set up like in the previous course.
Mhm.
So this time the system recognized my email.
Okay.
That's always happened in every class. Did you mention that the way things are done has changed?
It has changed since last year. So last year,
Figure it out. I'll try to figure it out, but I'm definitely not in it.
yeah, okay. That was my concern. That's why I wanted to bring it up. That is something that worked. Online folks, has anyone successfully logged to Pearson?
Not for this class.
They say I used Ivy Tech email.
I'm just afraid that if I change my information, will it affect my other classes? Because it's asking me to create an account, but I already do have an account. It's weird.
Well, it's something I can look at. Can't do it at the moment, but either you're gonna have to create an account using your Ivy Tech email. That's what I had to do. So even though I've taught here for however long, I had to create an account. And once I did that, I was able to. but I went through Ivy Learn. Okay, so go through Ivy Learn, don't go straight to the publisher's website, that would be bad. So that's the first hurdle, because previously we were using Ivy Plus. Okay. And should do more syllabus things. So my name is Ryan. I don't know if I said that already. My name's Ryan. And I've been here since 2013 for math. So a while now. And it changes every semester. Nothing stays the same ever. The only constant is it changes. So this is our textbook. Now, I have another question for you. At one time, they were going to require a certain calculator, and it was listed as you were to buy a certain calculator. Did anyone have that when they bought their book? Was it required to buy a calculator? When you registered for courses or anything?
I haven't received anything about it.
Okay.
I thought maybe you would tell us today.
Okay, so that, I can't contact students before the semester started, but I know it was listed as it was a requirement to buy a calculator.
But then again, I didn't do my diligence before class, so you.
I'm just interested what it was on your end, because I can't contact you guys until.
I
the
didn't,
semester begins.
I didn't look through, so.
So at one time, it was listed as this was the required calculator, that this was required, but it was incorrect. So I did catch that and I corrected it to what the correct calculator is. It's fine if you got this, you'll be fine. But then they changed it to the requirement was a TI 84 or 83 was the requirement. And you'll also be okay if you didn't buy it. If you have it, it will be great and it will be useful to you. But I am not personally requiring you to have it. Okay? I'm gonna show you another calculator you can use. I would suggest having some kind of calculator that's not just your phone would be useful. A scientific, at least this at most. Having something would be good. But I am not personally requiring you to own, anything other than a scientific calculator. You will definitely want to do exponents and logarithms and that kind of thing. That will be very useful to you. There will be certain things that I can show you that this can expedite your efforts, but there's also a lot of things online I can do as well, especially for homework and that kind of thing. We could use an online calculator, at least for the homework, to speed things up, and I know that that's going to be a bit of an issue, so that's something I wanted to bring up. So I am not requiring you to have the TI 84, but I know that it was listed. Okay? If you have it, I also have it, and it will be helpful, especially when we get into some really hairy stuff, it will be helpful. But I would highly suggest having at least a scientific calculator at your disposal throughout the semester. You do not need to own a physical textbook. That is not my requirement. If you want to, it is available. I do not need you to. And let's see, is there anything else I should briefly mention before I get into it? As I say, there is a huge amount of homework that's due each week. So this was developed to be a 16-week course. It's smashed into 8 weeks, and then we only meet half the time. So there's a huge amount of homework. Yes.
Yeah, I'm sorry to bother you, but in the textbook, we did teach you how to use 84.
There will be parts where it'll even reference the TI. So it'll reference that calculator, but I don't think there'll be any time where if you didn't have it, you couldn't complete an assignment.
Because it's my first time having familiar with it yet.
Yes, and there's many things it can do that we won't even touch. But yeah, there will be many times where I'll reference it, I'll show things it can do. That will be helpful, and you'll be able to use it for your own work. So this is how you'll be graded. But notice that the midterm and final are worth a lot. Okay, so this is a university level math course, and these are university level proportions. So 30% of the midterm, 30% of the final exam, which means if you're not a good test taker, this is not a good class. Right? So I'm just saying, if you fail the exam, that's not good. So I would suggest learning how to study for exams. Anytime anyone's entering a calculus course, I would say now is the time to not just complete, well, I got a 75% on the homework, I should be good, right? I'll get a 75% on the exam. No, right? That's 25% you've never even seen. That's not good, okay? So you can kind of get by with that mentality in the 100s, but once you enter in the 200s, especially something like calculus, no, even getting 100% on material, you still should study. And what is studying? Well, I'll try to go over it. It's condensing down information into what have I learned and what examples does that relate to, okay? And I'll also review with you before each of those exams. So I'll do a full lecture of just review for the midterm and for the final exam to prepare you for it, to do that. But as you go on to your 200 level, 300 level, 400 level courses, it's a bigger deal, okay? I know that in other courses and previous courses, you were probably able to get B's without studying at all, but now I would study. I would take time to study even beyond doing homework, okay? Especially if you have something like a 30% midterm, right?
Are the lectures available after?
Yes,
Okay,
this is
so
being
then-
recorded. You may be watching the recording right now. And
We can
I will-
return to the.
oh yeah, you can come back to it and see those
Will
examples.
it be on the Zoom?
It will be under announcement. So I will post, let me just finish what I'm doing
Alright.
now and then I'll do it later. So this is, I'll just end it with, this is how you'll be graded. Okay, this is the course setup. So that's the idea. Okay, but after class, where will you go? So, I will post all of my lecture notes, my screenshot, and the video I'm inside right now as an announcement after class. So I will upload all that information to you and you will have it. I've already started, you don't have access to this yet because I'm still working on it. But I've already started what I would call my lecture notes as the first announcement. This video will be posted inside it. My screenshots will be posted inside it, that kind of thing. And what are my lecture notes? Generally, I go through the book and I pluck out things that I need to reference, such as theorems, because I'm not going to prove any theorems for a brief calculus. I'm not going to do any proofs. I'll just say it that way. I'm not going to do proofs in class. It wouldn't be a good use of our class time, which we barely have any in the first place. So I'm not going to prove theorems. That might be something you would come into contact with in a 211 course, where they would actually prove the definition of a limit, prove the definition of a derivative, that kind of thing. But we're not going to do proofs. So I'm going to state, hey, the book said that this is true, so it is true. So that's what we're going to state theorem. So by theorem 1, this would apply. So that's awesome for you, which means you won't have to do delta epsilon proofs in this course, which are always a pain for first semester calculus, but we don't have to worry about it. We'll just say, well, by theorem 1, it works. So we'll just move on. So that's nice that we don't have to do proofs. And what I'm going to do is I don't know if the publisher loves this, but I just take screenshots of the theorems. I'll post them in the announcement, and then that'll just be my digital lecture notes. And I also have screenshots from problems I work on. So you'll see that as it goes on. I try to make it fairly easy to go back in time when you're reviewing. So if you go, okay, I know we were doing something with the definition of a derivative on week 2. And then you could go back, you could see the definition, you could see an example, and then you could even skim through the video and finally going through some problems. So it should be fairly easy to go back in time and do that. That's my goal. But this isn't posted yet, because I'm still working on it. But this video will be posted shortly after class. Not directly after, but shortly after. Okay. So I think that's it. I guess the first hurdle will be getting into Pearson. And then I might also have to direct people to Tech Help, because they would know more about how it connects with the publishers than I do. So I do apologize for that.
I already got in, by the way.
Oh,
Yeah.
so it can be done.
I just had to reset everything.
Just have to do, okay. And that was the same with me, even though I've been here for however many years, I had to set up a new account this month. So it's just, they changed the way things are. Okay. Questions, comments, concerns, complaints, or criticisms before I get into problems?
I have a quick question.
This class, we go till 3. Yes,
Oh, I'm sorry.
I think it's 350.
350.
3:50. Okay, so we've got some time to talk about that.
Is the final exam proctored?
It'll be online.
Proctored online?
It's online, it's timed.
Oh, okay, so not proctored.
It's timed.
Is
I'll
it-
let the software
Is
determine.
that a clue that it's open book by any chance?
Well, I'd say it's online. You won't be able to access, no, you will not be able to access your textbook.
Oh, really? Okay.
Because it's online. So you'll be locked down. So there you go.
But not.
Well, the final exam is not today, so let's not worry
I'm
about
very
that.
careful.
I haven't even-
I don't know if it showed,
But
but
I haven't even done the problem. What calculator should we have?
scientific calculator.
At least something with a logarithm and exponents, definitely. Okay, don't do logarithms by hand, but I'll also show, for the homework, I'll probably show things on Desmos.com, because it's better to show this than this, but I'll show graphing. I would just have some type of scientific calculator that's not from the dollar store.
Is there any way you can suggest some from Staples or Walmart, like some?
Anything like a
brand new-
TI 30, something like this is probably $15 and can do most of what we want. And then the TI 84s are great, but they're very expensive, and I think they're around $120. Those are my suggestions. I like Texas Instruments, but if you buy a Casio, which are generally 20% cheaper, I'll work with you. I mean, they do the same thing, it's just the buttons are out. So that's calculator. All right, what other questions, comments, concerns, complaints, or criticisms do we have in the first hour of calculus? Haven't done anything, haven't even done algebra problem. See what happens, okay?
Do we have to go to on campus for exams?
No, it will be, as I say, it'll be on your own time as homework. Okay, so it's on your own time. So you can come to campus and take your exam, but you do not have to, because it'll be on your laptop or whatever. And I don't know if it works for iPads. I have been able to do some of my work on my iPad, but I wouldn't suggest it. It's really a pain to enter everything in. I assume that would go with the phone too. I didn't try that. Previous years, I wasn't even able to open Pearson with my iPad. This is the first semester where I was able to open it and look at my work, which is kind of nice. I can look at it. I can enter things in, but it's really messy and not great. So I would suggest at least having access to a laptop or desktop or something like that for your work. No? Okay. So that's kind of what we're doing, but what are we learning and what is calculus? And what is the point? Is it just something that you're required to do? why would someone need calculus? Why does anyone need to learn it? Well, I would assume everyone has some kind of different major or something. But one of the common ones is business. Another common one would be some kind of engineering degree. And it could be medical. So those would be my three guesses of what you're studying. What are you studying? Business? Or well, I'll shove you in with business. I'm piling you in there. Say business? Business. Okay. You're gonna love, we're gonna go over profit, revenue, and cost in an algebraic way today. And then later we'll do it in a calculus kind of way next week. So there is a lot of, sometimes it's even called business calculus. Sometimes it's called brief. This one's called brief, but sometimes it is called business calculus. The good thing is no trigonometry in this class. So we don't have to do angles. What if the angle changes? What if we wanted to take the integral of tangent squared? We don't have to worry about it because we're not going to deal with angles. So very little rocket science will be involved, not zero. We will throw a rock off the building for one of our problems, but not a lot of our problems. A lot of our problems will have to do with business, or word problems will have to do with business. So that's good. So we kind of get that. But if you're engineering and medical, it's in there. Okay, there are those problems, and even my business folks, you will have to do those problems as well, just like I had to do all those problems in my day. But that's okay. That's why what it might apply to. But I haven't even explained what calculus is. So what is calculus? So it's kind of like it's a super algebra. But what if things started moving on you? Okay, so instead of x equals 12, right? That's algebra. Okay, so x equals this number. But what if the whole function started to move on you? Like, as customers' spending habits change over time, what is that change? So calculus really is, now the function is starting to move on. It's not just static. Algebra generally was static. Things are moving around. Profits are moving. It could be going up, could be going down. They're probably going down. Okay, you got to study how to slow that down, that kind of thing. So now the algebra starts to move on you. There's a time component to this. So you have the spatial component, or if you think of your chart, of your profits and revenues and that kind of thing, but it's over time. Things are changing over time, right? They could be escalating. Profits could be exponentially decreasing. Okay, that happens a lot. Things change quickly. So you can study how that might happen. And then another class, which is not required whatsoever, but if I can promote one other math class, it would be statistics. If you had 201 and some kind of statistics, I think you would be pretty good, because
It's a requirement.
that's probably good, because I could also think of a lot of applications that would go into statistics, especially if you took a calculus-based statistics, of how you could study large populations of people and how they change. But I'm going to focus on the change in this class. That's my goal. So I'm going to go into a few problems. Okay, now back to just what's the deal with this class and this weird guy. So just want to mention once again, so I'm going to teach kind of cart before the horse thing, teach the homework and shove in some theory and connect those for you. Just a personal pet peeve over the past 4 years. I really don't like it when students interrupt me and say, can we do my homework instead? Or my problem's different. Can you do that one now? No, I can answer questions later, but I don't think he would do that, but I'd be surprised. So, at least let me finish the problem that I'm talking about. And we can all talk about what if it was a negative 1/2, for instance, what if that was a negative 1/2 instead of positive 1? That's fine, but do my homework now, monkey, is not a nice way to talk.
Oh,
So it's just not nice to say. So don't do that to any of the teachers. There's ways you can ask people and get around it. But just from me to you, because I am doing the homework, so I'm kind of opening Pandora's box here with doing that. So let's get into some lines. See. Yeah. When I was in my undergraduate program, we would always joke that our professors would be like, as you've seen before, or you should already know this. It seemed like once a lecture, you're just waiting for it. You should, as you know, or you should already know this. It would come up every semester. So I get to say it now. As you know from a previous course, y equals mx plus b is a line, right? So, so we'll just bring that up. So y equals mx plus b. Before we get to calculus, we gotta review some kind of algebra, and that is a straight line, right? So the m is the slope, and the b is the y-intercept. That you should know, but just bringing you back from summer vacation. The slope is the rate of change, and it will come back again in a different way at the end of this section. So the rate of change. So we're talking about change. I said that calculus is the study of change, but this is slope. Is that related? Yes. So we're gonna kind of connect what you've seen with lines and other functions. Lines are nice because they're easy to study, but we'll connect it to things that can be a little bit more curvy. So that's the idea. So rate of change, you've seen that before. Hopefully you've seen a graph before. We have the x-axis is the horizontal, the y-axis is the vertical. You've seen that before. I can't promise it won't be frustrating dealing with Pearson and plugging in your function, but if you're graphing an equation, you only need 2 points. So I only needed to pick 2 points to graph. So I thought, okay, well, what if x equaled 0? Then the y-intercept would be 2. And what if x equaled 1? Then that would be, well, let's do what if x equaled positive 2? Then I would have y equals 1. And so that just gives me 2 points to work with, and that's all I need to make a line. So you just have to think, okay, well, 2 points, that would give me a line. So in this case, the slope is negative 1/2, the y-intercept is 2, and you only need 2 points to make a line. So that's the idea, and I assume that you've seen this before. But the first question is graph this. So I picked 2 points that were on that line, and I used the line tool to do so. Now we get into closer to calculus material. Okay. This equation here is one of the more important ones that we go. I shouldn't say equation. I should say is one of the more important ones that we'll go over today. It's going to be called difference quotient, and it's going to lead us into next week. Okay, so that's one to keep notice. It's already in my lecture notes, and I'll go over it again soon. But I need to go over function notation just to be sure that it is clear that you've seen this before and that you remember. So they give me some function g of x. So mine was x squared plus 4, and they say evaluate that at x equals -7. So what does g of -7 mean? -7 squared plus 4. Again, you should have seen this before, but if you remember it, I don't know. This doesn't mean G times -7, it means I'm plugging -7 into the function. That's the input. Whatever comes out would be the output. Okay, that's, so this is what I'm putting inside it. Once I do that, then I can value it. So this is -7 squared, which would give me 49, plus another 4 gives me 53, okay?
Professor,
Yes?
I'm so sorry to interrupt, but I'm not seeing anything on my screen. I'm not sure if I'm supposed to.
It says that I am doing it correctly. Does anyone see what I'm sharing?
Yeah, I can see your screen.
Okay. Olivia can't see the screen. Zoom says it is showing.
I can
What?
see my screen.
Okay. Maybe, Olivia, maybe you have it minimized. I'm not sure. Zoom says it's displaying it. All right. G of 0. What if x equals 0? So it'd be 0 squared, 0 times 0 is 0, plus 4 is 4. So we've both this before, right?
No.
No, okay. So I'm plugging in the number into the function that was given to me. This is g of x right here. This is g of x. It's telling me a number to input that in, then I'm evaluating.
I'm a foreigner, and this is totally foreign. So
Totally
I'm
fine.
trying to hear, but the level of understanding is at 0. That's just my personal problem.
Okay.
I was gonna talk to you after.
Okay. So it's not g times the number, we're inputting that number into g and seeing what comes outside. Okay, that's the idea. Now this is g of 7. So we're evaluating it. What if x equaled 7? So what is that? We would put 7 squared plus, which is also 53, which is the same as before of -7 because it was squared. So far, we're just inputting numbers into the function. The next thing they want is a plus h. So those could stand for constants, but we're not told what constants those are. So we'll put those in and just see what happens. So if I put g of a plus h equals a plus h squared plus 4. So I put a plus h in for x. So before that was x. Now it is a plus h as they asked. So you may ask yourself, okay, do I need to distribute from that point? Do I need to go a plus h times a plus h? So I tested and it said I didn't have to. So I left it as it was. Entered it in there. So far we're just inputting values into the function. Okay, and then this last one, this a plus h, that's just kind of practice that's going to get us to this difference quotient, which is the thing I have highlighted here, and that's going to be very important to us because that's going to take us to week 2, where we talk about the derivative of a function. Okay. So let's do this one right here. G of x plus h minus g of x over h. So what's h? Later we'll learn that that's the change, so how things are changing. But first, before we do that, let's see if we can do it. Okay. So g of x plus h minus g of x over h. Now what is g of x plus h? That means I'm plugging in x plus h in for x. So this is going into that x right there. So let's see what happens. So that would be x plus h squared plus 4. That's g of x plus h. And then I want to subtract off g of x. So g of x was given to me, x squared plus 4. I'm going to put parentheses so I don't make a mistake. I'm going to subtract off the original function. And then I'm going to divide by h. Then I'm going to see what happens. But what should happen is that you don't know this yet, but I'm going to tell you. The h should be able to divide out. We should be able to get rid of that bottom h there. It's not. So what I'm going to do is I am going to distribute this out and see if that's possible. So I have x squared plus h squared. X plus h plus h plus 4 minus x squared minus 4 over h. And I'm going to continue to distribute and see if I can't cancel any like terms. So I have x squared plus hx plus hx plus h squared plus 4 minus x squared minus 4 all over h. Okay. So if I did it right, the things that have nothing to do with h should cancel out. That's my goal. So I have x squared here minus x squared here, that cancels. And I have 4 minus 4, so that cancels. And so the only thing that's left are terms that have something to do with h. Okay. The only way you know that is that it's probably row. Just give you the hint. So we have hx plus hx, 2hx plus h squared over h. That's where we are now. And now I think I can get rid of that h in the denominator by factoring out h in the top. So h 2x plus h over h, and that reduces. So I'm left with 2x plus h. Okay. So that is the difference quotient of this. So my answer was h plus 2x or 2x plus h, equivalent statement. So you can write it either way. Now, why did I do that? Why would I do such a thing? Well, because the computer told me to do it, so I did. Okay, that's one reason. The other reason is it's going to lead us into the idea of how do these functions change over time. And this is going to be the study of how that happens. H is going to stand for the change of things and how that changes over time. So the difference quotient is one of the first big things we learn about. It's one of the big things we learn about in week 1. It's going to take us into week 2 when we talk about derivatives, which is one of the cornerstones of the course. So the arithmetic can be ugly, but that doesn't mean it's not important. We're going to see more examples of it, but that's the idea. Let's go to problem. I'm going to go to problem 6. See if I can find it. It looks like I'm finding the difference quotient again for this, but I'm skipping right towards the difference quotient and not starting with evaluating things. So what does the problem ask me to do? It says find f of x plus h minus f of x over h. Okay. All right. From there, I need to know what this function is in the first place. It looks like it's this. It's a quadratic equation. Okay. So let's see if we can build it. And then once we build it, we'll distribute it. We'll try to cancel like terms. And then we'll try to get rid of that h in the bottom and see if we can't do it. Okay. So let's find it. So f of x plus h minus f of x. That one felt like it shut my screen. So what is f of x plus
I
h?
don't want to fall in my head.
I don't either. I think they're just packing their stuff up on the rough. So minus x plus h squared minus 3x plus h minus 2. Okay, that's my x plus h part. And now I'm going to subtract off the original function. And I like to put parentheses around it so I don't make a sign here, which is easy for me to do. X squared minus 3x minus 2. That's all over h. So I want to distribute and cancel what I can. And from there, I'm going to try to get rid of that h in the denominator. And just see what happens. Okay, that's just me setting it up in the beginning. So I have my f of x plus h minus the original function. There we go. Now let's see what happens when we start distributing things. We have x plus h squared right here. We looked at that just a moment ago. We saw that that was x squared plus 2hx plus h squared. Seen that before. Now it's just multiplied by -2. So I can roll with the punches as far as that goes. So that's -2x squared minus 4hx minus 2h squared. And I'll distribute the -3 minus 3x minus 3h minus 2. I think those are the terms from the f of x plus h. And now I'm going to distribute this negative sign for the f of x. So that would give.
All right, yeah. I have trauma, like,
Plus,
it's gonna keep going no faster.
I'm not in control of the roof.
No, I mean,
I don't know. I don't know.
you don't,
So plus 2x squared plus 3x plus 2 over h. Now, what can I cancel? After just a lot of practice, I'm looking for anything that doesn't have to do with h should be able to be canceled. There should be an equal and opposite. So that's what I'm looking for. -2x squared, positive 2x squared. -3x, positive 3x. -2, positive. So I think it worked. You don't know that until you've done it many times, but if we do it right, everything that doesn't have to do with an h should cancel out with it. Okay, so what's left is what we need to focus on, and then from there, we'll try to reduce that h out of the denominator. So I have -4hx minus 2h squared minus 3h. I think that's it for the numerator. The denominator is h. That should be h. Go, that looks better. And now I want to factor out, since all three terms on the numerator have to do with h's, I could factor an h out. -4x minus 2h minus 3 over h, and the h's cancel. So we're left with -4x minus 2h minus 3. Questions, comments, concerns about how I did that one? Any questions? Online folks, any questions? So next week, we will let H approach 0. That will be the only thing I have to add for next week to talk about derivative, which is how this function changes over time. That's that. Right now, it's just a hard algebra problem. So I saved a picture of it, and I'll continue to do so for the other problems. Okay, let's see the business stuff. So an amount of money, A of T, in a savings account pays 5% interest compounded quarterly for T years with an initial investment of P dollars. The given equation, A of T equals P times 1 plus 0.05 divided by 4 to the 4T. If $90,000 is invested at 5% compounded quarterly, how much will be in the investment after 9 years? So again, as you've seen in previous class, right, we get this equation. Just in case it's been a while. I mean, they just give it to us, which was awfully sweet of them, but let me break down where these numbers come from and why. In case everyone remembers, I don't know. Is it clear what P is? The principal? That's the initial amount invested. So that's what got invested. Where does this 0.05 come? This comes from the 5%. So this is whatever is invested. Or I'm sorry, that's the rate which we get interest. So it's 0.05. So they converted that. Now, what about this 4 here? We have a 4 here and a 4 here. Okay. Is it a coincidence they're both 4? Where did the 4 come from? Are they related? Yes, they are. They are compounded quarterly. So 4 times a year, this account is compounded. So that's where the 4 comes from. So the rate is divided by the amount of times it's compounded. And then up here, it's 4 times the amount of years that it is invested. So that is the same 4. But if it's done over 10 years, then it was compounded 4 times 10, 40 times. It's compounded 40 times. So that's where it comes from. And if you allow me, I'll just write you a more general version of the equation. Let's call this n, and I'll call this n times t. N is just the number of times it's compounded. T would be the number of years. R is the number, or is the rate converted to a decimal, and P is the principal. Yes.
What if this investment is compounded yearly, every year?
Then the number of times it's compounded is once. So the n would turn into a 1. So this problem says compounded quarterly, so it's 4 times. If it was compounded yearly, that's only 1 time a year. So this n would be a 1. If it was compounded monthly, which credit cards are, credit card interest is monthly, so that would be a 12. N would be a 12. If it was compounded weekly, it'd be 52. Daily, 365. And then later we'll talk about what happens if it goes to infinity, which is what nature does, but it's for another day. So that's the general idea. And then now we just want to do a calculator check and see, can we get an answer? So they want after 9 years for my question anyway. So 9,000, 1 plus 0.05, 4. And then how many years? Well, for me, it was none. So we want to do a calculator check and see, can we enter this in a calculator and get an answer? If you have a calculator with you, I'll ask you to play along. So we have 9,000 times 1 plus 0.05 divided by 4 to the 4 times 9, which is 36. And I got $14,075.49. That's what I got would be the investment. But that's not profit, that's just what would be in the account after 7 years. We invested 9,000, we're getting roughly 14,000 back. So the difference would be the profit. Is it clear how I set it up, how I solved it, where the formula comes from, what kind of thing? Okay, this is just a review question. We're just talking about interval notation, set builder notation, and just trying to recall how these things work. So when we talk about the domain of functions, we'll need this type of notation. So what on earth does this mean? This is the set x such that x is less than or equal to -1. So that's all the numbers that are less than or equal to -1. Well, that's an infinite amount of numbers, so that's a lot. How do you convert this into interval notation? Well, visually, this is what we're talking about here. So we seem to be interested in -1. If it's equal to, x is less than or equal to -1, we usually fill in the dot to understand that that is being included. And then for this, I want all the numbers that are less than -1, including -1. So it would be this interval here. That's what I want to think about. That's visually on the number line, what it would look like. And then from there, how do you write this in interval notation? So we're going all the way to -infinity, or you can think we started at -infinity and are working our way to -1, but we want to include -1. So the interval, we want -infinity to -1, but I want to include -1. So I'm put a little bracket there, parentheses around -infinity, because we never reach -infinity. There's always a more negative number. We want to include -1, so I'll put a bracket there to show that that's what I want. So hopefully that's familiar, at least you have seen that before, I imagine. Right? We've seen that before.
I'm Albanian. That's why this,
You've never seen this before. Okay.
that's why I didn't know whether, the only math in America that I've done is algebra. And I got an A+ on that, but,
That's good. This is algebra.
so this was in 2004.
Okay.
So it's been a while, but my advisor said, just try it out.
Well, this is the interval. This is what I think the interval.
No, but the booms remind me of the bombings I've survived, so it's
I'm-
quite hard to pay attention with 140 people. But yeah, I know it's not your fault, I apologize, I'm not here fully. Oh, it's done.
Hopefully. If you need to take a break. But I can't control it. Let's see about this one. All right, so the set of numbers from -3, not including -3, to 4, but including 4. We want -3 . So x is greater than -3, but it's not including negative. And then with x being less than or equal to 4, we're going to include 4. Okay, so we're including that. So -3, +4. I do not want to include -3. I want all numbers that are just greater than. So usually what we do is we'll put a little circle there saying we're going to skip that one. And then we'll go all the way to +4. But we want to include that one. So that's what I think the interval is. Now, they didn't have the hole in the dot here. What they used was parentheses and a bracket, but I could still get along with that. That's okay with me. So that's the interval, I think. Now, how would I write that in interval notation? Well, that's starting at -3, but I don't want to include -3. And I want to go up to 4, but I want to include 4. So I'll use a bracket. That's what the interval should be. So the reason why we reviewed that is we're going to talk about the domain of functions, and to answer what is the domain of function, we need interval notation. That's why I wanted to review that. So the next question I'm going to go over is, what is the domain of this function? What on earth is domain? What is domain? So domain between me and you is just what you can put inside a function. It's the input. Okay, what you're allowed to put inside, what numbers are you allowed to put in the function? So this is the input. So with domain, it is often a lot easier to think about what you're not allowed to do than what you are allowed to do. Because generally, you're allowed to put an infinite amount of numbers inside the function. And there's often just a few that you can't. So what numbers can't you put? Well, here's Ryan's 2 rules for finding any domain, okay? So rule 1, if f of x is the square root of x, we want to focus on real numbers. So we want to focus on numbers that are not imaginary. So we want to take the square root of 0 or anything greater than 0. That would be fine. But I don't want to take square root of something like -1. So I have imaginary numbers. I'm going to not focus on that. Of course, we're going to focus on real numbers. So for this, I want x is greater than or equal to 0. That would be much better for me. So that way I only get real values. I can take the square root of 0. It's 0, because 0 times 0 is 0. And I can take the square root of any number that's greater than 0, like 4, which is 2. Right? That's no problem. But I don't want to take the square root of -2, because then I'm in imaginary number land, and I don't want to go there. So rule 1, let's stick with real numbers. Rule 2 is we can't divide by 0. We cannot. So the first rule is just restricting us to real numbers. We cannot divide by 0. If you start dividing by 0, you'll get things like 2 equals 5, and nothing makes any sense at all. All mathematics and logic starts to dissolve, so that's not good. So for this, x cannot equal 0. I cannot divide by 0. Those are really the only 2 things you need to look at for a domain. Everything else is permissible. Okay, we want to focus on real numbers, and we cannot divide by 0. Cannot divide by 0. All right. In this problem, what's going on? So I have g of x equals the square root of 3 plus 5x. So it's not the square root of x, it's the square root of 3 plus 5x, which is similar but not the same. So we just want to make sure that that's positive values. So I can put anything in as long as it makes that expression positive. So 3 plus 5x has to be greater than or equal to 0 by rule number 1. And then I could just use basic algebra to solve for that. So I could subtract 3 on both sides. I get 5x is greater than or equal to negative 3. And then I'll divide both sides by 5. And that implies that x is greater than or equal to a negative 3/5. So why is that true? Well, it's because I only want to focus on real values. So with the square root, I want to make sure that that remains to be so. And that implies that x has to be greater than or equal to negative 3/5. How do I write that in interval notation? Okay, so if I draw a picture, let's say that's negative 3/5 there. I want to include negative 3/5. That would be fine. And I want all the values that are beyond it. Okay. So starting at 3/5, but including 3/5 to infinity is the interval that I want to focus on. And that is the domain of the function. I claim the domain of g of x is from negative 3/5 inclusive to infinity, but never reaching infinity. So domain is the input and range is the output. Range is what comes out. But more often than not, we're worried about domain rather than the output. Any questions, comments, or concerns on how I solved for the domain of that function? Any questions about how I did that? Question 6. Use the graph of the function f to determine x or y to the nearest integer as indicated. Some problems may have more than an answer. 0 equals f of x. So they gave me a graph this time. I'm expected to answer the questions using the graph. So the question is 0 equals f of x. So that is kind of like y equals 0. My algebra days. Y equals 0. So what does x equal when y equals 0? Those are the x-intercepts. What does x equal when y equals 0? So that would be located here. That's an x-intercept. Here, that's an x-intercept. And here is an x-intercept. So it looks like from the graph, that'd be -2, x equals -2, x equals 0, and x equals 4. Would be those x-intercepts. So f of x equals 0 is kind of like saying what is the x-intercept? It's another way of saying it. I didn't really have to solve for anything, I just have to look at the graph and know what they were talking about, but that's half the battle. If not, most of the battle, is figuring out what does this question want. That's fine. All right. Let's go to the next one and see what happens. List the slope and y-intercept of a line. So this homework is going everywhere, but we know what lines are. Y equals mx plus b. Okay, so slope and y-intercept. Y equals mx plus b. Okay. M is the slope, rate of change. The y-intercept is that b. They gave me f of x equals 5x minus 6. Now that's kind of the same thing as y equals mx plus b. In that case, the slope would be 5, and the y-intercept would be -6. B equals -6. In this problem, they want an ordered pair. It's an ordered pair. That means the point. Where is the point? Which means you have to do both coordinates, x and y. So ordered pair, there's a vocab word. So that's the x and y coordinate. Where does that exist? Well, we know that b equals -6. That's the y location. If it's the y-intercept, x equals 0. So this point must be 0, -6. As you've seen in previous classes. Now, we don't have to just stick with lines. I mean, ideally, you would learn a system of finding what is the rate of change of a function that's not just a line, but something that curves up and down, because that's what you're going to be focused on outside of school. These things that go up and down all the time. So you can find what is this rate of change and where did it start. Okay, so that's where we're going. But we're kind of trying to connect the idea of a line with what you will be dealing with, which is just raw data. So we're trying to go from here to here, trying to go from high school to just a file of raw data and how to analyze that. So that's what we're doing. But if you can come up with a function that is relatively close to what you're seeing in the real world, then you can find what the change is. Be the slope of that. So that's where we're going with this. Find the slope and y-intercept of the line given. It's just a nice elementary algebra question here. So we have 10x plus 5y equals 5. Well, I know that y equals mx plus b, and m is slope, and b is the y-intercept. But they gave me the line in the general form. So one method I could use is I could rearrange the terms so it's y equals mx plus b, or the other way is I could find the x-intercepts and then find the slope myself. I'd do the other way. The easier way would just be to rearrange the terms. So that's what I'm gonna do. So 10x plus 5y equals 5, and I'm gonna try to get it in y equals mx plus b form. So I'll just solve for y. So if I was to do that, I could subtract 10x on both sides. And I get 5y equals -10x plus 5. And from there, I can divide both sides by 5. So then I get y equals -10 divided by 5x plus 5 divided by 5. And should probably simplify and reduce if I can. -10 divided by 5 is -2. 5 divided by 5 is just 1. So I think it's y equals -2x plus 1. So I think the slope is -2. I think the y-intercept is 1. So that's my slope. That's my y-intercept. So m equals -2. Y-intercept equals 1. As an ordered pair, that would be 0.01. to answer the question. Questions on that? Let's try this one. Oh, this one for a particular reason, that was how we have to enter the information, so. When we get to the answer, I'll mention something. So use the given point, and slope to write an equation in the point slope form. And part B, the equivalent equation in the slope intercept form. So this question is giving me information about a line and it wants it in a particular way. And I just wanted to review what those vocab words were. It's in the lecture notes as well. I wanted to slow down and talk about that. Okay, so here they give me the slope and a point that the line goes through. So they give me slope and a single point. So I have slope and a point. So I can find the line. Find the line. I either need 2 points, I can find the line, or give me the slope and a single point that goes through the line. Well, I know if it's a line, y equals mx plus b. So I have somewhere to start. They gave me the slope, 6, so I can substitute that. So y equals 6x plus b. I don't know what the y-intercept for this line is because they didn't give it to me, so I'm gonna have to find it. Now, one of the ways I could do that is just plug in the point that they gave me. So I'll just replace the x and the y with the points they give me, and then I'll solve for the y-intercept. So I'm gonna plug in -5, -3 into my y equals mx plus b to find -3 equals 6 times -5 plus b, and now I can solve for b. So I have -3 equals -30 plus b. And if I add 30 to both sides, I would get 27. So b equals 27. Now I know the slope and I know the y-intercept, so I know everything there is to know about the line. Y equals 6x plus 27. And this is the slope intercept, which is what they wanted in part B. So that's the y equals mx plus b down there. But they also wanted the point slope form. Point slope form. So where does that come from? Let's do it blue. Point slope form. It's y minus y naught equals m x. That's the formula. And I just need to plug in the information that they gave. So y minus -3 equals 6, x minus -5. And the negative would make it positive for this particular problem, just the particular numbers. So this would become y plus 3 equals 6, x plus 5, just because of the negative makes it positive. So that's what I mean. The point slope form. but it's really just rearranging terms and to the particular version they want. And for all the problems, they give you a hint. But I wanted to give you a hint in class. And then in-person folks, you can see the other screen. Online folks, I'm sharing this. I have this in the lecture notes now. Just in case you refer to that, that's the definition. That formula. So you have that. It's also in the example. I have a few more problems from this homework I wanted to go over. Let's see. Find the slope, if it is defined, of a line containing of 2 points. The equation of the line containing 2 points in slope-intercept form and the ordered pair identifying the lines y-intercept, assuming that it exists, if appropriate, state whether the line is vertical or horizontal. Okay, so we were given 2 points. And they roughly said find the line. They said find the line. But how do you find the line from 2 points? Usually what we do is we find the slope and then the y-intercept. That's usually our method of attack. So y2 minus y1, x2 minus x1 is the slope. So 5 minus 5 over 1 minus 5 is 0 over negative 4 is 0. So the slope is 0. Slope is 0 for this. What does that mean? The slope is 0. That means that this function is a constant. There's no change at all. There is no change here at all. The rate of change is 0. No change. But next week, when we talk about functions kind of up and down, talk about when the function is not curvy at all. And here it's no change. So this is a constant function. And it just looks like y equals 5. That's what it looks like. Y is always 5. And the slope is 0. So it's horizontal. And the equation is y equals 5. In algebra class, it's always presented, it's have problems, but it's always quickly moved on from something like this because they're not very interesting. So it's a good thing to just remember how that works. Later, we'll even talk about derivatives, and the derivative would be something like y equals 5. It can come up in other ways too. So just wanted to recall something like that. Here is a applications problem, and I wanted to at least demonstrate an example, something like this. So we're planning to produce a new graphing calculator for the first year. Fixed costs for setting up a new production line to $1,575,000. The variable cost for each calculator is $10. The sales department projects that we'll sell 175,000 calculators will be sold. First year of the price will be $73, complete the remainder. So this is where cost, revenue, and profit will come up. So this is kind of the beginning of our 3 friends: cost, revenue, and profit. Cost, pretty self-explanatory. This is what it cost us to produce these calculators. And we're going to write that as a function. So the cost function, C of X. So how do I build that? They're telling me just to get the factory or production line going, it costs this amount of money just to start. And it costs $10 to produce a single calculator. Each calculator we produce, it costs us $10. So I think the cost function would be something like 10x plus that setup fee, which is a very large setup fee. It's $1.5 million. Almost 1.6. But that's the cost function. Now the revenue is what we got coming in. So if we're selling this for $73 each, then we, however many we sell, we would just times that by 73. So I think the revenue function would just be 73x. It's listed here, yeah. So the revenue function, R of x, since we're selling it for $73 each, it's just 73 times x. Now, how do you find profit function? What is profit? You have costs, you have revenue, that's the money coming in. So how do you determine profit? If I have a lemonade stand, it costs me $75 to buy all the materials. I sell lemonade at $3 a glass. How much profit do I make? If I sell 100 glasses, that kind of thing. How do you determine profit? What is profit?
How much you make.
How much you make. So that'd be like the money coming in minus the money we spent going out. So profit would be revenue minus cost. That's what I think profit is. So P of X, let's just say P of X, profit, that's gonna be R of X minus C of X. It's the money coming in minus the money going out. That's the profit. Okay. So from that, in this problem, we would have 10x 73x minus 10x is 1.700. So we just want to subtract it away. So revenue minus cost, that's the profit. So 73x minus 10x, 63x, that's $1,570,000. That would be my profit equation. And then it asks, what would be the expected profit if you sold those projected sales? I just plugged the number given into my profit equation and evaluated. So I'll write a little note how I did this, but listen to that. Last part, break even part. Break even. How do you determine the break even point of a business? You have all the setup costs, you have money coming in. How do you determine how much you have to sell to break even? I would say when profit equals 0, that'd be one way to say it. Or you could take your cost divided by how much you're selling it for. That would be another way of doing it. So that's what I did. I took this cost divided by that slope, and that tells me when the profit equals 0. So I'm gonna write for our notes, just the break even. Break even. It's kind of like when P of X equals 0. That's a very math teachery way of saying that, but that's the way I'm gonna say it for us. Because when we talk about quadratic equations, exponential equations, and that kind of thing, this will also come with this, not just lines. So we can think, okay, when profit equals 0, that's when we break. Here is an example of, they give us a graph. We have to find it from the graph. So we have R of X, C of X, P of X. Okay. So how do you do this? Well, you look at the graph. Luckily, the graphs are straight lines. So I was able to do this, just because it was a straight line. But because it's a straight line, hopefully, in some way I can show that. So they're all a straight line. The revenue, the cost, and the profit. So just by looking at the graph, I can say, oh, well, here's 2 points. I can make the line y equals mx plus b, and I can find. But that's how I was able to do it. I just looked at the graph, noticed, okay, they're all straight lines. I can just see 2 points. Like for instance, my revenue, where does it start? Where does it end up? That's 2 points. I know the y-intercept, so I can build them fairly quickly. That's the idea. We don't have to know any more information from it. So just a little heads up on that one. And then this is also review. This is in the review section in the book, but I wanted to go over it. So I'll need it for later. And that's quadratic equations, vertex, opens up, downward. These are all things that are going to come up over the next few weeks. So I wanted to do this problem together. I'm given quadratic function, f of x equals x squared minus 12x plus 11. And it wants me to find the vertex of the parabola. So the vertex of a parabola visually is something that is either the highest point of a parabola, or you could have the lowest point. Say it's right there, or something like that. So that's visually what it is, the vertex. If I threw the pen up in the air and it made a parabola, it would be the highest point the pen made. That's, kind of the idea of the parabola, but that's going back to the rocket science stuff. So that's visually where it is. That's the idea. So it's either the highest point or the lowest point. It could be your revenue. What was the highest revenue? What was the lowest revenue? Or it could just be an algebra problem. But there's a formula for it because it's high school math. So we know that. So the vertex is located at negative b over 2a. So that's your formula where that x point comes in. And then to find the y point, you plug that in to the original function. And that is your vertex. That's where you find it. You've probably been tested over this many times. The quadratic formula. Saw that a lot in high school, I would imagine. It's just this bottom part here. That's where the vertex is located on the horizontal, and where it is on the vertical, you would just plug that point in into the original function. So let's see that in action. For this function here, that would be negative 12 over 2 times 1. So that would be positive 12 divided by 2. That's 6. So x equals 6. If I plug that in the original function, that will give me where the y coordinate is. F of 6 equals 6 squared minus 12 times 6 equals 11. I think we get negative 25, is that right? So we get 36 minus 7. Yep. you can find it from the formula. And then from there you can plug that into the original function and find the output. Okay. Now, what is this line of symmetry? In my Algebra 2 course, we go over that for the entire week of finding just these two things. Here, it's just embedded in one problem you do. But you've already found it. So the line of symmetry is where these things are symmetrical. And that we just found it. That's the line. X equals negative b over 2a. It's the same line. It's x equals that number. So that's the line of symmetry for the problem. So we already found x equals 6. Parabola is opening upward or downward. Do we remember that from high school? Parabola is going upward and downward. Do you remember those shapes from high school? Yeah. Right? You remember it curving down or curving up? That's familiar. So we call this up, and we call this down. Okay. And I always remember it down as the frown. It's frowny. Up as a cup. Looks like a cup, or it's smiling. So up, it's positive. Down, it's frowning, it's negative. So that's how you can remember it. And then that will also tie in to when we get into second derivatives. This is going to come up again. So down, frown, think negative, up, cup, positive. That's the idea. Now this has a positive leading term, x squared. So this is upward. You can graph it using a graphic calculator. You can visually see that happen. But just noting that the constant in front of it is a positive number. It's true. So this is upward. And then finally, what are the x-intercepts for this? What are the x-intercepts? Well, that's where y equals 0, or f of x equals 0. So if f of x equals 0, then that function equals 0. So we have x squared minus 12x plus 11 equals 0. And I'm sure in high school you had to solve 1,000 of these. You can either use the quadratic equation, or you can factor, or use more advanced techniques if needed. But I think I can just factor this one. So what are the terms? What are the factors of 11 that add to negative 12? The factors of 11 are 1, 11, and 11 and 1. So not many choices there. So 1 and 11. And for them to add to negative 12, I would need them to both be negative. So I can factor this as x minus 1, x minus 11 equals 0, x equals 1 over 11. See, x-intercept ones here. So that's review, but I thought we should review instead of just assume. Another domain question. What is the domain of this function? So if we remember what I was going on about earlier, you have something like f of x equals 1 over x. X cannot equal 0. We cannot divide by 0. So that's the only thing I need to avoid. Just need to avoid dividing by 0. So what would that interval be? So if I just skip 0, look like. So from negative infinity to 0, 0 to positive infinity are the two intervals I need to include. how do you write to add two intervals? Sometimes they'll just write a comma, but here we're gonna use the capital U, meaning the union, and that's how we're gonna put those two together. So I'm gonna put a capital U here. That U right there is the union of sets. It's like adding this set and that set. Putting them together, that's my capital U is what it is. So that's the union of sets. If you took finite, you'll know what happens when the U is upside down, that's the intersection. That's what they would have in common. Capital U here is the union, and I want both of those. So this integral or this integral will work for me. Is that familiar from, I'm gonna remember that from before, previous courses? Okay. This one, if the last one made sense, this one is very similar. Now the denominator is just squared. Still can't divide by 0, so I want to skip over 0 again. That's really the difference. An interesting thing is when you plug in a negative number or a positive number, the square takes the negative away, and so you get the same thing back. That's something to keep in mind. Okay. Find the domain of this function. Well, what restrictions do we have for the cube root? What restrictions that was not in my two simple rules to find any domain. This wasn't listed. I can plug in negative numbers for cube root because it's what number times itself 3 times equals that. Like for instance, the cube root of -8, that exists, that's a real number. So there is no restrictions as far as the cube root goes. It looks like the square root, so my radar kind of goes up as far as that goes, but I can plug in negative numbers there. That one's okay. So there's no restrictions for that. So the domain is all real numbers. Similar thing, find the domain and function. You just can't divide by 0. Don't want to divide by 0. So x plus 3 cannot equal 0, which would imply x cannot equal -3. It's the only number in this. So negative infinity to -3, union -3 to positive infinity. And then that capital U means the union. Right, and then really going back to high school, solve the equation using a quadratic formula. Do we remember the quadratic formula? I'll give it to you in case it's been a while, but x equals -b plus or minus b squared minus 4ac over 2a. What am I referring to with a, b, and c? You have a x squared plus bx plus c equals 0. So you steal those constants from that and you plug it in. It's required that you knew that before you came here today. So I'm assuming you have at least seen it before, and now you just have to remember how to do it. This week is remembering how we did that. Let's see. That's really all the time I have for the first homework. Really gone on quite a lot for the first homework. I wanted to give you a jump start on it. Let's just talk about this one. Rewrite the following as an equivalent expression with rational exponents. I have set the root 7 there. How can you rewrite this with exponents? This is the denominator. This would be the numerator of that. Call that the square root of x is x to the 1/2. The cube root of x is x to the 1/3. Fourth root of x is x to the 1/4, and so on. And you could also do fourth root x cubed is x. Of course, those are some examples. But that's something to review, is to be able to go back and forth between exponents and radical expressions. But that's what you're doing this week. You have a week to review that. I'm just introducing it today. So that'll be on the homework. Okay. And recall, go down here to another question. So here is a word problem. Let's say you have no idea even where to get started. You can always just click view an example. It'll walk you step by step for each problem, okay? Which is great, but time consuming. So you don't want to have to do that for every single problem, but it's available for every single problem. So you have help for all the problems, but time consuming it is. Okay, it's really the time I have allotted for the first homework. So I take a small break, get a glass of water, and then we're going to talk about the second section homework. But let's look at it. For this week, we have 4 things that are due. The first homework, which is what we've been looking at, and then there's a quiz over that. So you have a time quiz, first homework, time quiz, and a second homework, which I'll take a break. So that's the schedule, pretty much consistent unless it's a midterm week or final week that we left in the schedule. So I'm gonna take a break until 3 o'clock, which is like 7 minutes, and come back and show you as many possible questions as I can and the second homework. Okay? All right, so I'll be back in 7 minutes. So the second part of our lecture has to do with limits. And I kind of think of that as the beginning of our class. Is limit, that's usually what I think of as the beginning of calculus. So I should probably go over what is a limit, so we've seen it before. A limit is when a function is approaching a certain point and it gets really close, maybe infinitely close. The thing that's interesting to us at infinitely close is that we can look at functions that are not even defined at a certain point, but we can go, well, what if they were really, really close to that point? And what would happen if they approached that point? That kind of thing. So that's maybe the beginning of the discussion of calculus. What if this function was approaching this? Nice thing this class is that we do not need to prove. Just state it as a fact and move on. But in calculus 211 or IU calculus, usually you have to do proofs, and usually you have to prove that the limit, write proofs that the limit exists, but we don't have to. We can just state that it exists. So theorem 1, as x approaches a, the limit f of x is L, that's the limit, where L is a real number. If the left-hand limit exists and the right-hand limit exists, and both are L, then the limit exists. So for the limit to exist, it has to exist on both sides and be the same number. We're going to get into that in homework. The converse of this theorem is also true. The limit as x approaches a, f of x equals L, then it follows that the limit as x approaches a from the left and the limit as x approaches a from the right are the same. So for the limit to exist, I need it to exist on both sides and be the same. Otherwise, the limit doesn't exist. Now I'm going to show you a bunch of homework examples, just break down theorem 1. But I'm not going to prove theorem 1, and I'm not going to ask you to prove it. Okay, so that's the nice thing. We won't have to do any delta epsilon proofs. It exists. We're just going to practice how this works. So looking at the homework already, I'm going to start playing around with ideas. How this might work. Okay, so as x approaches 5, the value of 2x plus 7 approaches. What's going on here? There's no phrasing of limit at all, and I kept going on about limits. What's going on? So this is like f of x equals 2x plus 7, and it's saying if x got really close to 5, what happens? What happens? So as x goes to the number 5, what happens? Well, the first thing to try is just plug in 5 and see what happens. Okay, what happens if I just plug in 5? So 2 times 5 is 10 plus 7 is 17. So I think it's approaching 17, but all I do is plug it in for this example. Later we'll see that it'll be discontinuous and it'll only exist on one side. You have to deal with that. But from the beginning, it's not too bad. Question 2, the notation blank is read as the limit as x approaches 2 from the right. Choose the correct answer. As x approaches 2 from the right. So this is how we write limit. Just write LIM. And x approaches 2, and it says from the right. What does that mean, from the right? It's talking about over here. So we're going to 2 from this direction here. So we're going backwards. We're gonna approach 2 from this way. So we're going left, but we're coming from the right. So we put a little plus sign saying that we're gonna be from the right. Plus sign means from the right. So from the right is that plus sign. Okay, so that's how I would write the limit as x approaches 2 from the right. If it was from the left, I would put a negative sign. It's just a notational thing, how we write this down. Okay. The notation, the limit as x approaches 4 for f of x is red. The limit as x approaches 4 of f of x. So x is going to 4. X is going to 4 from the left and the right. Limit as x approaches. The notation, the limit as x approaches 5 with that little minus sign, that means from the left. Okay. So the limit as x approaches 5, that little minus sign right there, that means from the left. From the left. The limit as x approaches 5 from the left. So that's the notation. So we have to know left and right. Decide from the graph whether the limit exists. If a limit exists, find its value. The limit as x approaches -3 of f of x. They didn't give me the function, they just gave me a graph. So I just have to look at the graph. Okay. So as x approaches -3, where does that happen? So x is going to -3. It's getting closer and closer and closer. If x is 3, not y, it looks like it's going to that point, +1. And then on this side, it's going to the same point there. So both left and right, it's going to the same point. So that's good. So it looks like from both left and right, it's approaching +1. So they kind of agree that's where it's going to end up. We see that there's a hole there, but they agree that they're both going that way. So it looks like it's going to +1. So I think the answer would be 1. The function is going to 1. Okay, but I had to look at the graph to find it. So the limit as x approaches -3 of f of x equals 1. Even though there's a hole there, the limit agrees that it's going there. That's it. So notice that that's the y value. I'm entering the y value. So it's going towards that. Does it make sense? What I'm talking about? Sort of. Use the graph of f shown on the right to find the given limit. When necessary, state that the limit does not exist. The limit as x approaches -1 from the right. So that plus sign there. Let me write down what it says first. The limit as x approaches -1 from the right. See what's going on here. So going to -1, where's that? So that's x equals -1. What's going on here? From the right, it's going here, which looks like it's +5. From the left, it's 6, 7, 8. So from the left, it's turning into 8. From the right, it's turning into 5. So they do not agree. So I don't think the limit exists for them because they disagree. From left and right disagree. Even though there is a point, if I go to that point, I know where it ends up. It ends up at 8. The limit doesn't exist because they don't agree Does it help when your teacher does this a lot? Is that helpful to the student? I mean, so. What do you think? Does that make sense? Kind of, sort of, maybe, not? Okay. So limits. I think the confusing thing is, when does it exist? Even though there might not be a point there, the limit could still exist. And then you could evaluate it even though if the limit doesn't exist. So there's a lot of trapdoors around with that kind of thing. Of course, the homework goes over all of them. So this is a different example. We have kind of a straight line and then a dot, and then what looks like a parabola. So 3 different things going on. We want to look at the limit as x approaches -1 from the left. What's going on? So from the left, that's that line. So as it gets closer and closer and closer and closer to -1 from the left, it looks like it's going to +1. Looks like as I get closer and closer and closer, I end up at +1. I know that the limit doesn't exist because they wouldn't match up. If I go from the right, it would get closer and closer and closer to -3. So the limit doesn't exist. But from the left, I can say, well, I think it's ending up at +1. Does that make sense? The limit doesn't exist, but I can still answer this question. That's confusing. Right? So I can still say the limit as x approaches -1 from the left is 1, even though the limit doesn't exist. This is where calculus gets its reputation of being confusing. Similar. Get a different graph. The limit as x approaches 4 from the right. Let's see what's going on here. So the limit as x approaches 4 from the right, the plus sign means the right. Okay. So from the right, what's going on as we approach 4? Get closer and closer and closer and closer to x equals 4. It looks like it'd just be 0. Not really seeing any problems. And if I went the other way, it would also work out. So I think the limit exists. I think it equals 0. So it doesn't have to be broken. You can still have the limit. Limit still exists even if it's continuous, but we focus a lot if it's discontinuous. Use the graph of the function f shown to estimate the indicated limits and the function value. So the first thing I needed to answer was the limit as x approaches -1 from the right. -1 from the right. Well, that's 0, -1. It looks like it'd just be 0. It's just be 0. Okay. And then what is the limit as x approaches -1 from both sides? So do they agree? If they agree, then we can state that the limit exists and give that point. So going to -1 as close as I can. It looks like it'd still be 0, no matter which way I go. Or which way I go, it's just going to end up being 0. So it exists. So that's 0. Now find the value of the function. That's plug it in. Okay. So that's a whole nother thing that we practiced before. I think if you evaluated -1, it would also equal 0 by the graph. So the limits have to agree on both sides for the limit to exist. But that Still doesn't guarantee you that the point exists. You can also just evaluate the point. And that could be a point of contention as well. Okay. Right. Very similar, but let's see what happens. Use the graph. We want to find the limit as x approaches 3 from the left. As x approaches 3 from the left. It's getting closer and closer and closer to 3. And that looks like that would give me 0. So as x gets closer and closer to 3, it looks like I would get 0. If I did that, just looking at it right now, if I did it from the other side, it would agree that as x got closer and closer to 3 from the right, I would get 0. But what's funny is, maybe not so funny, is that the point doesn't actually exist. If you evaluated the point, you would get to number 1. Jump there, discontinuous. So even though the limit exists, it doesn't mean the point's there. So there could be a difference between continuous and the limit existing, which is tricky. And that's something you have to think about this week. So I think the limit exists from going from the left and from the right. And the limit, the total limit exists. And if you evaluated it, it wouldn't be 0, it would be 1. That could be right. So if I evaluated it, it's not 0. Turns out it wasn't 0, it was 1. So that would be kind of funny. Let's do one more like this, just to ensure that it's at least approachable this week. So use the graph of the function, estimate the indicated limits and the function value, complete parts A through D. So find the limit as x approaches -2 from the right, from the left, and the limit if it exists, and point. We're interested as the limit f of x, I think, as x approaches -2. So as x approaches -2, well, from the left, it's going here. It looks like it's getting closer and closer to -4. From the right, it looks like it's getting closer and closer to +4. So those do not agree. So I claim the limit doesn't exist. I could state what it is from the left, from the right individually, but totally it doesn't exist because they do not agree. And then if I evaluated it at that point, what would I get? I would get this one, because that's the dot that's filled in. So if I evaluate that point, I choose the one that's filled in. Makes some kind of sense. Is that clear? So for the limit to exist, they have, both left and right have to agree, but the left and right can be stated what they are. Okay. So that's what I have here. So from the right, it was 4. From the left, it was -4. The limit does not exist. And if I evaluate it, it was -4, which was the dot that was filled in. So 20. Use the graph of f shown on the right to find the given limit. When necessary, state that the function does not exist. So it doesn't exist, doesn't exist. So we want the limit as x approaches -4. And remember, it has to agree left and right. As x approaches -4, well, from the left, it looks like it's growing to infinity. So from the left, it looks like it's just going positive infinity. From the right, it looks like it's going negative infinity. So that's two different things, for sure. So the limit doesn't exist because those don't agree. And it doesn't ask me, thankfully, so I shouldn't even bring it up, but if I tried to evaluate that point, I'm not even sure what I would say. Because at that point, it's both positive infinity and negative infinity. It's going two different ways. I don't even know what to say if I was to evaluate it. I guess I would just say it doesn't exist. Because it's going positive infinity and negative infinity. I'll just assume that's not zero. No, it doesn't. It's kind of perplexing, but that's how I would answer that homework question. All right. So find the limit as x approaches infinity, x approaches zero. We haven't done a question where we approach infinity. We've done one where function was approaching we go to. So what does that mean to approach infinity? Well, for us, it just means think when it just goes long term, x is really big, and it just keeps getting bigger. Keeps going to the right. Think about that. So that's how we'll think about it. So as x gets really, really, really big for this function, so the limit as x approaches infinity with 1 over x minus 2, as x gets huge, I mean huge, think trillion times trillion times trillion, trillion to the trillion squared, big, 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 big numbers. What's going to happen? 1 divided by a giant number is itty bitty, right? Like 1/100th is a penny, 1/1000th, 1/1,000,000th, but I'm talking really big and getting bigger fast. Okay, that's going to go so small you can't believe it. Okay? This term will just get so small as that x gets huge, huge, huge. This term pretty much just goes to 0. So I'm doing a lot of hand waving to say, as x approaches infinity, 1 over x will just go to 0. That's one of those things in 211 you would prove, or your teacher would prove. We're just going to say it as a general fact. It's a lot easier. And it is true if you just play with the numbers. If you just look at 1 over x, and as x gets huge and just keeps getting bigger, this whole thing gets so small. As the bigger the x, the smaller this is a reciprocal relationship. So the limit of f of x, let me write this. This will just go to 0. That part will go to 0. So what's left? If this term goes to 0, the only thing left is -2. So in my homework question, the whole thing, as x approaches infinity, this whole thing will just go to -2, the number -2. Okay, and you can see that in the graph that I chose. As x gets bigger and bigger and bigger and bigger, it'll just get closer and closer to -2. But I want to try to explain why that would be. That's because that 1 over x is going to go towards 0. So whatever's left will be counted. Now, as x approaches 0 is the other part, and that is an even trickier concept. We'll call that is. So the limit as x approaches 0 for 1 over x minus 2. So what happens if I divide by 0? 1 divided by 0 minus 2. I don't know what it means to divide by 0. We don't even have a language that defines that. So nothing knows what that means. There's no language or logic that happens. So we have to look at it from the two different directions. And that's where we were looking at before, where it goes to positive infinity, negative infinity. So as x approaches 0, you see, okay, if you're going from the left, it's going to negative infinity. From the right, it's positive infinity. So it's like negative infinity, positive infinity. Paradox. See, so we're just gonna say, no, we're not gonna do that, okay? We're not gonna let it hit 0, and you see that the limits don't agree, and we can't evaluate the point. So as x approaches 0, the limit does not exist. Because it's going positive infinity, negative infinity. Two extremes in two different directions. Doesn't exist. You can't know what that means. And you just by the definition, the two limits don't agree. So we said it doesn't exist. Classify the statement as either true or false. The limit of the number 4, like y equals 4, as x approaches 2 is 4. Yeah, I can plug any number in y equals 4 and I get 4 back. So it's kind of like a trick question, but just wanted to. It's not very hard, but I thought we should go over it. If y equals 4, then no matter where x is, y equals 4. So that's true. That's true. Okay. Classify the statements as either true or false. Now, this is something I'm going to have to refer to the book, and I posted it already in my lecture notes for you, because I'm just going to have to state it as a fact. But it says classify the statement as either true or false. Let's just break down what the question is first. If the limit as x approaches 1 for some function equals 8, would it be true? Can I say, am I allowed to say that the limit as x approaches 1, the same approach, of g of x squared would equal 8 squared? So I'm not even talking about the answers. I'm asking you a question. Can I say this? Well, I'm not justifying it with any answer. I'm just going to say, look at what the book says. So I have it in my lecture notes for you. Online folks, I'm changing the screen. I've already posted. In-person folks, let's look at that limit properties. So I just stole this from the book. And it says limit property 2, the limit power function is at the limit of the base raised to a power. So the limit of f of x to the n would be the same thing as L to the n. So it kind of works the easiest possible way it could, which is good for us, right? So if I square the limit gets squared. It works like it should. Everything's good. Okay. So that's nice. I'm just stating it's a fact. I'm not going to prove it. I'm not going to prove it during class. So I think because of the limit property, if the limit as x approaches 8 of g of x equals 8, then by limit property 2, I can say that the limit of x approaches 1, g of x squared would equal 8 squared, which is 64. So by limit property 2, that's true. Okay. But then they say, is it true that it's 16? No, so that's not 8 squared, that's 2 times 8. So they tried to trick me, but I'm also trying to jam in the lecture here as well, what it should have been. So it should have been 64. Should have said 64, but it's 16. So the limit squared is the limit squared, which makes sense. But my homework question said, should it be 16? No, because that's 2 times 8, not 8 squared. Just wanted to try to point you with what's going on later. And maybe even try to explain, like, why is that false as opposed to just it's false? What True, so you can square the limit and it would be the limit squared, that's fine. But they just didn't give me that option for the homework question. Okay. Classify the statement as either true or false. If f is continuous at x equals 6, then f of x does not exist. No, if it's continuous, it has to exist, means there's no holes in the function. So it exists, it's just a trick question. So that statement is false, because it would exist. If it's continuous, then of course it exists. Okay, let's look at 27. Classify the statement as either true or false. If the limit as x approaches 7 exists, then f could be continuous at x equals 7. Yeah, it could be continuous. It's not even a strong statement. It could be. It didn't even say it is. It's just that it could be. So yeah, I would say that's true. That's true. There's no jump there. Okay. Use the theorem of limits of rational functions to find each limit. If necessary, state the limit does not exist. The limit as x approaches 2 of the function 3x plus 1. Well, this is so easy, I can just do it. You don't have to even call upon any theorems or anything. This would just be 3 times 2 plus 1. And that's just the number 7. That's it. Just plug in the number. Use the theorem of limits of rational functions to find the following limit. The limit as x approaches -6 of the function x squared minus 6. So the limit as x approaches -6 of x squared minus 6, let's just plug it in and see what happens. It should be fine. Should be fine. That's not very rigorous to say a mathematician to be like, it should be fine, but it should be fine, right? So -6 squared, 36 minus 6, 30. I think the limit is. What about this? Find the given limit. So the limit as x approaches -3 for the function -x squared plus 7x minus 8. So -3 squared. Make that exist. -9 minus 21 minus 8. Plugging in the value and entering the minutes. That's not too bad. Right. This one made me confused. First tried it when I looked at this. Well, let's see if it confuses you. So use the theorem of limits of the rational functions to find the limit. If necessary, state that the limit doesn't exist. The limit as x approaches -1. And my thought was, oh, it doesn't exist because I'll divide by 0. I misread it the first time I looked at this problem. So the limit is x equals -1 of x squared minus 8 over 1 x would be -1 squared minus 8 divided by 1 minus 1, which is not 0. It's 2. So -1 squared is 1 minus 8 is -7 divided by 2. It's -7/2. It certainly exists. No problem. Just plug and chug. Find the indicated limit. The limit as x approaches 3 for the function root 5x minus 1. Let's just plug it in and see what happens. 5 times 3 minus 1 would be 15 minus 1, 14. So I think it's just the square root of 14, which is just a number. No problem. These kind of connect that difference quotient. Okay, so skipping all the way to problem 40 here, I'm given a function f of x equals 7 divided by x. First thing is they want me to find the difference quotient, which we saw in the first homework. The first thing I have to do is find the difference quotient, and then they give me a table of values that I need to plug in and see how this goes. But the first thing I need to do is find. So that's one. So f of x plus h minus f of x divided by h equals 7 divided by x plus h minus 7 over x over h. Just setting it up first, seeing what happens. Okay. From there, I can say that 1 over h times cross multiply 7x minus 7 times x plus h divided by x plus h. I'm gonna keep doing my algebra and see what happens. 1 over h, 7x minus 7x minus h, x squared plus hx. I distribute this term, negative 7 times x is negative 7. And negative 7h. Divided by x squared plus hx. 7x disappears. Equals negative 1 over h, negative 7h, x squared plus hx. I claim that this will reduce, so you'll just have a negative 7 if this was the same numbers that you had, just a negative 7 up top. So that's good. Negative 7 divided by x squared plus hx. So that's my difference quotient. This. And the way I got that was I just followed the formula. All right, now I'm gonna save a picture of that, post it after class, but now I'm gonna have to clear it because I'm gonna show you what I do with this table of values. But I saved a picture of this, I'll post it after class. So that's algebraically how I got the difference quotient. Now that we have that, what are we expected to do? It says, what if h was 2, 1.1, 100? What would happen then? Okay, so what would happen then? Well, what was my difference quotient? Negative 7x squared plus hx. So what if x was 5 and h was 2? Negative 7, 5 plus 2. So I just plugged in chunk. If you have a graphing calculator or scientific calculator, you can enter this in once and then just change this 2 value to that's the only value that's changing. It's getting smaller and smaller and smaller. You plug these values in and you do the same thing here. Negative 7, 5 squared plus 0.01 times 5. And you'll see how the function is changed as it gets smaller and smaller and smaller. Next week, we'll talk about when h goes to 0, what that means. Right now, we're just letting it get smaller and smaller by the table of values. You said we end at 45 or 50? Okay. I'm gonna show as many problems as I can, so I'm gonna keep going. We've got a couple more like that. Let's see. I know it's boring, long, and I know I'm going it's possible. Okay. Piecewise function, what's going on here? Given the function f of x, piecewise function, so I just have to look, see what's going on. Is it continuous at 4? X equals 4, why or why not? Well, if I look at x equals 4, that would apply in my problem right here, where x is less than or equal to 4, so I do have a value there, so that's fine. So I would say that the value is continuous at x equals 4 because the limit exists. Okay, so both sides would agree, it's fine. But I assume you've seen piecewise functions before, they're everyone's least favorite, because every piecewise function is different. But it's worth at least reviewing what they even are. You just kind of have to take them piece by piece. Same thing with here. Is this function continuous at x equals 9? So we have when x does not equal 9, when x equals 9, that's fine. Is it continuous there? Well, at that point, I suppose it would be. Okay, is the function continuous? No. Is it continuous at x equals 9? Yes. At that point, it would be. So that's kind of a trick question. But it's just the way they phrased it. And then this will be the last thing for the week that I need to go over, and luckily it's easy. It's connecting right back to lines, but it's a vocab phrase here. So average rate of change means slope. So average rate of change is just slope. Okay, and so they give me 2 points and they give me a function. So we can go as fancy as we want, but it's just the slope. It's just the slope. So they go pretty fancy, I would say. So you have f of x2 minus f of x1 over x2 minus x1. But that's just going back to middle school, just finding the slope. Or maybe 6th grade for you guys, when you learn the slope. Probably early on. So they can call it as fancy as they want. And they can use notation, but it's the same thing we learned your whole life. So in this case, what would that be? I just need to plug it in. So that's 3 times 6 minus 3 times 0 divided by 6 minus. So that's 18 divided by 6, which is the number 3. So it's finding the slope. It's the same thing you learn whole. They just call it something different. The reason why they would do such a thing is because this is connecting slope with a function like next week when it's not a line. So we could have like a quadratic, but we could find the average rate of change even if it's quadratic. So we're kind of going beyond that. What that means with the rate of change for something that's not a straight line. And I have 6 minutes. Showed one like that. I think you could do that one on your own. Let's do this one and I'll call it a week. An object dropped from rest from the top of a tall building. Maybe our tall building, there's a lot of things dropping during this whole lecture. Planet X falls at a distance of 18t squared. Where t is the time in seconds. Find the average rate of change of the distance from 5 seconds to 8 seconds. The rate is the average velocity or speed of the object. Okay? So that sounds pretty fancy, but it's just find the slope. And you've been doing that your whole life. So that's not that fancy. Okay. So average rate of change in our book looks something like this. That is just the same equation, or I should say formula, as slope. So I can just find it. So let's plug in the points. The later one is 8 seconds. So I could go 8 squared minus 18 because of the formula. 5 squared divided by 8 minus 5, which is 3, of course. And it's here. 64 times 18 minus 18 is 25. 3. Hit 234. Average rate of change, or said another way, what is the slope? So 234 feet per second. It sounds pretty heavy, but it was just fine with slope. Okay. All right. So that is 2 weeks, less than 3 hours. That's a lot. And if you think you're tired, imagine standing up in front of class and doing it. It's tiring. And this is way too fast. This is the best way I've come up with teaching this class. It's not great, but at least you've been introduced to the homework. And they're not entering the homework with no connection to what I did. So I focused on homework rather than focusing on theory. Even though this is nearly unbearable, at least you've seen the homework when you're on your own. But you have a week to do those things. 4 things due. So you have homeworks 1 and 2 and quizzes 1 and 2. That would be what is due. And your homework for today is just getting into Pearson and getting it started. If you haven't or can't do that, we need to make sure that you can. But clearly it can be done because someone did it during class, so it can be done. Okay, that's good. So 4 things, and the quiz is really just a timed version of the homework. It would just kind of motivate you to make pretty good notes for yourself while you're doing the homework, so you can go back to the quiz. You get 2 attempts for the quiz. Makes the best score. As the week progresses, do not hesitate to ask me help math homework. I do not understand question 34. Will you help me? Yes, I will. I like helping with math. Okay? So don't hesitate to reach out. And I'll be in campus. If you're around, we could meet up at first too. Okay? And there's also a tutoring center downstairs, almost directly below us, like directly below us across the hall. That'd be another good resource. Calculus is hard and this is too quick, but the other resources to complete it. So, okay. So I'll stick around after class for any questions, comments, concerns you might have. Other than that, I'll see you.